Hi, let's take a look at this problem. While standing in an elevator, you see a screw fall from the ceiling as it moves upward at a constant speed of 2.2 meters per second. The elevator ceiling is 3 meters above the floor, and I've drawn that in this picture. Okay. How long is the screw in the air? And the question is there more than one way to solve it? So I'm going to solve this problem one way, and I'll make another video to make solving the problem the other way. In this first part, I'm going to assume that the elevator is moving up at 2.2 meters per second. And I'm going to assume the acceleration of the elevator is 0 for this part. Okay. In one of my other videos, I'm going to have the elevator accelerate while it's going up at 2.2 meters per second. Okay? There's two ways to solve this problem given these conditions. You can solve this from an observer on the ground or solve it based on an observer in the elevator. And the first way I'm going to do it is to solve it based on an observer in the ground, a stationary observer. So if a person is standing on the ground, what do they see? Well, at t equals 0, the screw starts falling. While the screw falls, the elevator floor still moves up. Person wants to know how long it's in the air. Person wants to know when is the position of the screw equal to the position of the elevator floor. So we want the position of the screw equal to position of elevator floor. Okay, so that means I have to write an equation for the position of the elevator floor. So I'm going to write y floor equals, so let's take a look. What's the elevator floor doing? Well, initially it's a distance y naught above the ground. By the way, I'm defining down as negative, up as positive. We can actually set this arbitrarily to 0, but I don't want to do that in this problem. We'll just call this y naught. So the elevator floor is y naught above the observer, or above the ground, and it's moving up. So the position of the elevator floor is increasing by this amount each second. And so the position of the elevator floor can be written as y naught plus 2.2 meters per second times time, because every second the elevator floor moves up at a rate of 2.2 meters per second. Now, what about the equation for the position of the screw? Now, the screw comes off while the elevator is moving up. That means when the screw came off the elevator ceiling, it was moving at the same speed of the elevator. So let's write an equation for y screw. Well, its initial position was this much off the ground, 3 meters higher than the elevator floor. So I write as y naught plus 3. It was going at this speed. And since it's falling, it's undergoing motion at constant acceleration. And we're saying down is negative. That's the position of the screw. I want to find out when the position of the screw equals the position of the elevator floor. That's when, that's how long the screw is in the air. Okay, so let's set these two equal to each other. Now remember, half of 9.8 is 4.9. And I forgot the plus 3 here, sorry. So we do get some cancellation. And y naught cancels. And you notice the 2.2 t cancels. And what we're left with is 0 equals 3 minus 4.9 meters per second squared t squared. Of course, y'all can solve that. And because I have limited space on my board, I'm going to just tell you the answer, because y'all know how to do the algebra. You get 0.78 seconds. So it takes 0.78 seconds for the screw to go from here to here. And we did this problem from the reference frame of a person standing on the ground. Okay. Next, what I want to do is the same problem, but we have a person standing in the elevator.